All right, so you're going to need something to write on, like notes, like just notebook notes. So we've talked about mean and standard deviation with binomial, but we did not talk about an interpret sentence. We talked about mean of geometric, but I didn't get into standard deviation. So one thing that I've noticed as I've been talking to people about, like helping them through certain problems, is understanding what the problem is actually asking. So when I write P parentheses, if it is binomial, what letter do I usually choose to use with P parentheses what? X. When I do with geometric, I usually choose to use what letter? What does X actually represent? Number of what? Number of successes. And that's where I probably took that for granted because I realized a lot of conversations all the time when people didn't really realize what X meant or like couldn't have written that down themselves. And then what is Y? Y should be more obvious because the only thing we deal with geometric. Number of trials until first success. So just making sure that we're clear about that part of it. What is our equation for binomial mean? U equals what? N times P. Standard deviation is sigma equals what is my equation for geometric mean? And what is my equation for standard deviation? We gotta talk about. So this is 1 minus P over P squared. The whole thing's under square root. That one is the only one that, like, interpretation wise, like I could go through the long process of getting you there and understanding standard deviation, but most of you probably wouldn't want to hear it. Geometric is not as intuitive as the other ones are. All right, so interpretation of these, when I interpret mean for a probability distribution, and we start this with if what? If many, many. Remember that sentence. So if many, many what? Thinking not this, but was on last test. If many, many individuals are randomly selected, we expect the, I don't remember what I called it generally, average number of whatever to be about. Well, it works a lot like that. I don't know if I have that next or skip the slide. So if we randomly select, oh, this one doesn't have many, many in it. I need that. Oh. So the only thing that's a little bit different about this is we have a set number of trials, and y'all can go ahead and be writing this down while I'm talking. We have a set number of trials. So like I roll the die 8 times. How many times do I expect to get the number 1? So we do it a certain number of times, but we're repeating that entire 8-time process many, many times. Because if we repeated it once, we just have an answer. So if we did it over and over, what would we expect it to be? Which means I got it. And instead of writing a completely separate sentence for standard deviation, I'm just putting it together as it's a continuation of that sentence, but I'm going to write it separately so that, like, I'm saying the top part is interpretation of mean, the ... bottom part is the interpretation of standard deviation. So when I give this on a test, I want to see it sectioned off as like this part standard deviation and this part is mean. But instead of starting all over with standard deviation to rewrite the mean part, we're just making it like it's one sentence. Oh, I didn't type this symbol. That's standard deviation symbol in there. This one is missing a word. That top one's missing a word, and you should know what it is. Right where my cursor is. What? I should say average. You can do it just like that, and then just section and be like, this part is mean, and this part is standard deviation, and not like, 'cause you know how when we do standard deviation, like we did before, we like started all over and then read a whole sentence. So instead of making you do it like that, I'm just gonna let you do it together, not start over. But so yes, this is fine. And we're gonna practice one a little bit too. Anybody still writing that? So while we're at it, we're going to go ahead and write the geometric one too. Mini-me trials, on average, we'd expect to do the process a certain amount of times before we. So I'll explain it once y'all write it down because I don't want to mess you up because you're going to keep writing. So definitely expect this on your test, obviously. With both of them, you have to interpret it. I did send you guys out a message yesterday that said we moved it to Friday, definitely. The reason I didn't really want it to move to Friday is people who aren't going to be here Friday, like that part of it. But it still ended up being a better choice than trying to finish too quick. So if you do not attend Friday, I told you have two options. You actually have three options just because it's over the weekend. If you want to get it done before and you want to stay after school on Thursday, we're throwing that as an option. I don't know if anybody would choose to take that, but that technically would be fine. Or on Monday, you would take it during class and then watch class at home, or take it before school, after school, or during your lunch. And with most of y'all being done after fourth period, it shouldn't be that big of a deal, hopefully. But we'll kind of see how things go to see how we want to do it after this. All right, is anybody still writing this one? All right, these aren't the ones I want to do. Yeah, that's 3 probability scenarios. Without me explaining anything, I want you to answer all 3. So I don't care if you write these down, if you just do it on scratch paper or whatever, but I want you to attempt to answer all 3 without talking to anybody. Or just answer all 3 without talking to anybody. You're going to be able to talk to people, but I just want you to do it without talking to people first. Yeah, and all these calculators up here are clean if you want to grab them. And if you have an issue with one, skip it. All right, part A is a what kind of problem? And I'm going to write out everything like it would need to be on a test. You were probably just writing out to figure out what kind of problem it was, so I wouldn't expect you to have everything I'm writing written down. So if this were a test, I would want to write geometric. I am defining success as a 2. What's my probability of success? And I am finding probability that y is what? Equal to what?
7.
Because what did we say y is?
The 1.
The number until our first success. So how many did we get until we got our first success?
7.
So that should be a 7 there. And that gives us what? I'm going to skip and go to C. What kind of problem is C?
I know.
Because our X is number of 2's, number of successes. So it's binomial. I'm still defining success as rolling a 2. Got a written roll of 2 up there. Voterize it. The number was. Here, I would write roll of 2 just because it happens to be the X is 2. I'm not going to count for that. I need P, which is still 1/6. I also need what? Which is, I also need X, or I can write it as P parentheses X. So P parentheses is that X what? Equals 2. So I'll be doing PDF or CDF. PDF. Just to review the equation, which I wouldn't have expected you to write this down. What goes on top? 7. What goes on the bottom? What's my first number here? Fraction. 0.6. How many of those do I want? What's this fraction going to be? 5/6, because how much is left? How many of those do I want? Because 7 minus 2 equals 5. So you don't have to plug them that way, just going over what the equation is. And you end up getting 0.2344, is that right? Now, part B is not geometric and it is not binomial. But if I asked you this question, not in the middle of chapter 6, most of you would get it right. But I'm asking you in the middle of chapter 6, so you are trying to make it binomial geometric, and you probably have a hard time with it. So think through what we want here. How many times are we doing something? 7. Okay, what happens the first time? I rolled a 2. What happened the second time? What happened the third time? And how many of those did I have? What is my probability that I roll a 2? So this probability is 1/6, this probability is 1/6. What's each one of those going to be? Which, obviously, this is not the smartest way to write it. The smartest way to write this would be I want this how many times? I want this how many times? And that gets you your answer. And if we were not in the middle of chapter 6, you guys probably would have answered that correctly and been fine with it. But because we're specifically in chapter 6, you're trying to make things fit. So just kind of like a look ahead 4 months from now when you're taking your AP exam, you have to be able to look at a problem and be like, does it fit as binomial or geometric, or is it something that I think through? Like logically, like thinking through it just like concept-wise. And sometimes there are ones that can be done both. Like geometric technically can be done realizing it's geometric and not realizing it's geometric. So when I said that the other day of like, sometimes I solve geometric and don't think through the fact that, hey, this is geometric to solve it, you end up doing it like one of these problems. I think, okay, well, the first one I didn't get it, second one I didn't get it, third one I didn't get it, fourth one I did. So geometric kind of works more like concept there. Questions with any of those? This is going to be the last thing we do. So 2 questions. With both of them, A is the probability. With both of them, B is mean standard deviation. And interpret. And I don't care if you're talking with people while you do this one or not, but I want to make sure that we're all on the same page with the difference between mean standard deviation, interpret, sentence. I'm going to stop the video here so that I'll start the video again when I get to going over the answers, just so that y'all can pause it.